Okay, so let's start by, okay, so we're gonna be following these 4 steps: import necessary libraries, the reading of the document to see how the text is displayed, find patterns in the text in order to arrange the respective data you're trying to retrieve. And then we're gonna arrange the data accordingly using a data frame for future export. So starting with step 1, in this case we're gonna import fits, which is a powerful PDF reading library for Python, and we're gonna import pandas for the allocation of the data. Now step 2 is to read the file. Again, we're gonna be reading this file in order to find any patterns in the text, because first we're gonna transform this file into pure text, into only text. So to do so, let's say PDF, right now we're gonna locate the document in our directory where we're working on, which is this one, document. So the PDF is called document PDF. Then we're gonna read it using the fits package, PDF document. This is gonna be, let's see, it was fits open PDF. Now this is gonna, fits, what it does here is that it turns the PDF into a readable code. So here we can actually play with it. However, let me show you. Also, we're gonna create a full text string. Why? Because although we are reading the text here using fits, we're opening the file, it's not very readable, it's not a string based, and we want to turn it into a string in order to find the patterns in the text that is gonna be produced from the reading of this file. We're gonna be using a for loop because I think that's a very good tool for iteration. So let's use a for loop, and we're gonna iterate through every single page of the document. Right now, as you can see, I have 25 pages. So we're gonna iterate through each of one and get the text of each page. Page number, in range len PDF document. First, we're gonna load each page as we're gonna load each page. So page is gonna be PDF document. Load page is gonna be page number. Then we're gonna transform that load page into text, into strings. Text is gonna be page get text. Now that text is gonna be appended or added to the full text, which currently is an empty string. We're gonna convert it into a continuous string, and let me show you what I mean. We're gonna add it. We're gonna add each page text to the full text string. Therefore, it's gonna be increasing and increasing as it iterates. Text. Okay, now, and let's see how the entire text looks. Okay, look, as you can see, we're putting everything as a single string. So this is a single string, a single text. But I mean, of course, as you can see, there is no tabulation, there is nothing, it's just pure text. This is where your pattern recognition, your subjective pattern recognition comes into play. So let's see, as you can see, every single time there is a date, especially the 12/31/25, below that date, a new entity starts. The name of the company, type of the company, then the address, number, etc. As you can see, for example, again here, it follows the same pattern. The name of the company, apparently the second part of the name of the company. So again here, part 1 of the name, part 2 of the name, part 1 of the address, part 2 of the address. I suppose that's the person, a phone number, an email, and the license, and then again another date. Part 1, and apparently there is no part 2, so that's cool. Part 1 of the address, part 2 of the address, that name of the person, the number, the email address, and then license part 1, license part 2, license part 3, and then another date. Okay, so we're gonna separate this entire string. Okay, before that, by the way, now that we display the text, we go to step 3, find patterns in the text in order to arrange the respective data you are trying to retrieve. So let's do that. Now that we have that, let's separate the text using the pattern that we just found. We're gonna separate the text based on these dates, because as you can see, every single row ends with these dates, which means it's a pattern that we can use in order to segregate and separate the data each column, which is basically what we're trying to do here. So we're gonna use the split function. Individual rows. That is full text, and this is the beauty of having it on the full text, because that's a single string. We can break it down into multiple strings or lists, which is what's gonna happen right now. Let's see how it looks. As you can see, the name, the address, the name, the address, the license is always at the end, etc., etc. As you can see, all of them follow the same pattern except here. So as you can see, this is why does this happen? Well, because as you can see, in every single page you have a page number at the bottom and also another set of headers for each tabulation. It's not continuous, so that's okay. We can also find another pattern to remove this. This is the beauty of programming is pattern recognition, creativity, and expertise. If you have those three, you can do anything. You can do anything at all. You can combine any expertise in programming to find, create, modify, cancel, or delete anything you want. It's just a matter of finding the right pattern, having the expertise to exploit that pattern, and direct action. So what we're gonna do is we're gonna split each of the rows by each indentation, which will give us a list, which will give us each row in a list. So let me show you. As you can see, okay, so the list, the string now turned into a list, it has always an empty string at the beginning. So let's see, and let's see if that's true. We can print the first character of a list of the first item of a list for all of the lists. Yeah, look, let's use emptiness, emptiness, and emptiness. Besides this one, of course. So let's remove. So if we know that all of those, if we know that the first item is the same for all of them, we can remove it. Now, as you can see, we have deleted all of the first ones. Now, before putting this into an Excel, we need to do something about these types of lists, which, as you can see, start with the page number, then the headers. Okay, and I believe the headers are always the same. So that's another pattern. We know that this type of list, malfunctioning list, let's call it, always start with the page number, and then they always have 1, 2, 3, 4, 5, 6, 7. 7 headers ahead of them. If you don't believe me, so for instance, take this example, and let's go to another similar example, this one. So the page number 1, 2, 3, 4, 5, 6, 7. That's another pattern. So we know that. We know that for those type of malfunctioning lists, there is always that pattern. Therefore, we need to remove the first 8 items of that list. How are we gonna do that? Well, pattern recognition once again. So we know that for those type of lists, if the first item starts with the word page, that means that this is a malfunctioning list. So let's remove all of the malfunctioning lists. Okay, now that we have that, now that we have removed the impurities of the malfunctioning lists, we need to use again pattern recognition, which is a crucial tool in programming. I would say like it's a vital tool in programming. And let me know I'm using the correct adjective. Absolutely necessary or important, essential rule in programming. Okay, so what we're trying to do here is we're trying to find a pattern in order to segregate or to, and I don't know, every time I use the word segregate, I feel bad. I don't feel bad, but I feel guilty because I know segregation is linked to racism and, you know, all of the impurities that America has. But, well, America not, United States, because America is the continent. The US has. But anyway, that's another topic. I don't want to get political as of now. But we're gonna use the word segregation as a form of separation. The action or state of setting someone or something apart from others. That's what I'm using for. Not the second definition here. The enforced separation of different racial groups in a country, community, or establishment. I don't want to do that. I'm saying this. The action or state of setting someone or something apart from others. Okay, so I'm gonna use that definition. All right. Now, in order to segregate all of these lists into a tabulated form, and all of them following the same structure, we need to make sure that we first assign the headers for each one. So what we're looking at here, we're looking at the name of the, this is gonna be part of step 4. Allocate into data frame headers. So the headers are name, company name. These are the variables we're looking for in this list. Address. Person. Phone number. Email address. And licenses. Okay, those are, we need to put every single list together in that order. So, but as you can see, we cannot do that using mathematics. We cannot do that using logic. Like, we cannot say that the first item of the list is always the name, the second one the address, the third one the person, because that's not the case. As you can see, for example, here, the first one is the name, sure, that applies. The second one is also the address, that applies. But the third item is part of the address, it's not the person. So that, or logic there will fail. So we need to use pattern recognition to find a way to segregate this list into those 5 variables only. So basically we need to make these lists 6 items long and make sure that each item corresponds to each header. How are we going to do that? Well, segregation by pattern recognition. So I can see that every single, for example, every single email part contains the @ symbol. So we can see that, we know that if an item of a list contains, which by the way, the items of the list are strings, if an item of the list contains an @ symbol, that is the email address. And that means that every single item after that item that contains the @ symbol pertains to the licenses, as you can see. So every single item that is after the item that has the @ symbol will always be the licenses, as you can see. The item after the email is always the license. So that saves us some time. And we know that the item before the email is always the phone number. And then before that is the name, okay? So we have that always. So let's start there, and then let's see other patterns, okay? Okay, now that we know that the items that contain the @ symbol are the emails, and next to them are other attributes, we can iterate through every single sublist and segregate that. So for example, for attribute in range len attributes, and why am I using range len? Because we're going to be dealing with indexes and numeration. As you can see, we're going to be using numbers to identify which item is which. Okay, so if, as you can see, we'll print the entire, we'll print the entire, now, as you can see, we print every single email address. So that's cool, that's cool. Okay, as you can see, we are segregating the email based on the email. And I think that's enough. I mean, now we know, we have a reference point within each sublist that can be used to identify the rest of the items of the list. It's like we know where the emails are located. So now we have a point of reference. We know where things are based on this email on the index. We know that after the email is going to be the licenses and before the email is going to be the rest. Therefore, let me print attributes again. Okay. So that's the email. Now after the email, it's always gonna be the licenses, right? So let's do that. And then in order to know that, as I was telling you, we're using ranges because we're gonna be using indexes here. So using the index of email in the sublist, that is email index, it's gonna be attributes index of email. So basically, in which position is the email found for each sublist? Let's see that. Okay, 5, 5, 6. As you can see, on places like 5, 6, 5, 4, sometimes 5, 5, 5. So the email is always on place 5 most of the times, but sometimes it's in place 6, 4, and even 7 here. Okay, using that, if we print the sublist from that index only, we're gonna be printing all of the licenses. So for example, okay, we have identified where the email is located based on its index. Right, as you can see, if I print this, so all of those numbers indicate basically where the email is located. So where the email, the index of the email within the list. So which numerical value is the email within the list? Maybe it's in the 5th place. So every single, so on the number 5 for this list is gonna be the email. Number 4, the item 4 for this list is gonna be the email. Number 6, number 7, etc. So knowing that, we know that, as you can see, and let me show you, if we print this, if we print the list, we can see that the licenses are always after the email. So here, as you can see, this is the email, there is always the license. So knowing that, using that index of the email, we can print only the licenses. So attributes, attribute, and as you can see, we'll print a list with only the licenses. Oh, my bad. I don't want to include the email. There you go. So as you can see, using the index of the email, we knew we could find, we were able to find what the licenses are, where the licenses are, basically. So let's actually convert them into a string, singular string, because we want a string, right? So licenses, we're gonna use joint here. Join the attributes, attribute one. Now print licenses. There you go. Now we have a string with the licenses. There you go. That's our second attribute that we found. Now, let's find another patterns. Print attributes. Okay. We know also that before the email, it's the phone number and the person. So, phone number, using the same logic, phone number is gonna be the attribute -1. Print phone number. And why -1? Because it's before the email. As you can see here, let me make it clearer. All of those are phone numbers. Interesting. Look. So that doesn't always apply because there are extensions, which means that we need to set a rule there. Okay, so in the last step we use the email index to find the licenses. Now we're doing the same for the phone numbers, but as you can see, it works if we do a -1, as if we use the rule that the item before the email address is always the phone number. That works, but not for all of them. As you can see, here's an extension. I don't know what this is. Another extension. So we need to also make sure, just as what we did at the beginning to remove the headers and the page numbers, we need to find a rule, another pattern to remove this and actually retrieve the phone numbers instead of the extensions or rare text. So we know that every single phone number starts, the item is a phone number if it starts with a number and if it has two of this symbols. Ta-da! Just like that, we have acquired all of the phone numbers now. And why? How do we do this? Is because if a dash is in the item also and the item starts with a number, that's a phone number. So we do nothing, we pass. However, if it's not, it means that the phone number is before that item, that it's faulty. So we have that phone number now. Now, we also can use this to find the person. So this is email address. This is licenses. Address. This is the phone number. And now the person. Okay, now in order to find the person, we're gonna use the phone number index to find the person, because as you can see, the person comes before the cell phone number all the time. So let's use that fact, that pattern, to find it. So the person is gonna be attributes phone number. Let's see, it's gonna be, let me break this down. Phone number index with first, as we cannot use the attribute here because as you can see, sometimes the phone number is two spaces before the email address, not one. So we cannot use it all the time like that. Therefore, we need to find the index ourselves, which is easy. If we use attributes index phone number, we know that the person phone number index and let's see if we have the person here is before the phone number index. Let me remove this to make it more appearable. Therefore, we have all of the persons right now. Department, estimating departments in Michael. So that's good. We have now that person. All right, now that we have the person, we are left with, we need to find the title, the company name, and the address. which I purposely left them at the end because those are the more tricky ones, especially for this, because you can see some addresses are split by 2 or even 3 strings, 3 items. And some of the company names have 1 or 2 items on their possession. So we know that the first item of the list is always part of the name of the company, right? We know that. However, we cannot know whether the second one will be or not. I mean, sometimes it will. And let me find an example. For example, here, 3 power electrical contractors, Inc. That Inc. is part of the name of the company. However, that doesn't happen with all of them, as you can see. But we know that the address items start where when the first item of its type starts with a number or a PO box. So if an item starts with a number after the name and or a PO, that means that's the beginning of the address. Okay? So let's say we know company name. That's gonna be attributes 0. That's gonna be always the first part, right? Company name. So what we're saying here is that if the second item does not start or PO not in is digit or PO in attributes. So here what we're saying is if the second item of the list starts with that number or it has PO on it, we pass it. We don't count it as part of the company name. Otherwise we do. So let's see if that theory applies. Let's see, ALC apparently does. I mean, but we need to do it with a space, of course. Okay, we have collected the names. Now we know. Now we're left with the addresses, and as sometimes is useful for, you can leave the hardest thing at the end. So as you can see, we left the address at the end, which is the most tricky one because it's very variant and it depends on the string manipulation. But now that we have everything, now that we have collected all of the remaining items, we can only focus on the address, which is pretty easy if we know that the address finishes always before the person, right? So the item before the person will always be the end of the address. And we know that the item after the complete name is gonna be the start of the address. So we can use those two indexes. Let's say the address starts at index 2 and the address ends at index 5. We can use that to compare them and put them together based on, so from the list from index 2 to 5, that will be the address all the time. That's another pattern recognition technique. So let me show you how to do this. We're gonna remove the pass here and we're gonna add, because we know that if the second item of the list starts with a number and it has a PO or it has a PO, that's the beginning of the address. So address is gonna be the attributes the 1 all the way to the person. Attributes index person. However, if it's not, if it's part of the address, we're gonna have the address as joint attributes from the third place all the way to attributes index of person. Now let's print the address and see how it looks. And just like that, we figure out. However, yeah, what I'm seeing here is that, anyway, and just like that, we get all of the address. Of course, some of them are incomplete, but as you can see, it's not a program. It's that people manually inputted them like this. As you can see here, we're missing the capital letters at the beginning. That's a very bad grammatical error, and people should know how to read and write. But that's fine. I mean, that's fine. We're gonna let them do that. But as you can see, well, so for some of them, but before, let's put all of our newly acquired attributes into a list. The list that we're talking about, that it's 6 in length. So it has 6 items in this order. So attribute list. So we're gonna have company name, followed by address, followed by person, followed by phone number, followed by email, and followed by licenses. So if we print that attribute list, we have collected our emails or strings. We have transformed the initial full text into our order of list, into our ordered list. So now we have every single list, and if you get the length of these lists, all of them is gonna be the same. 6, 6, 6, 6, 6, 6. Why? Because we took the care and detail and pattern recognition to put them together like that. So now this facilitates the allocation of this data into a uniform tabulation on Excel. So this number, let's see, print length should be the same as this number, or at least very similar. Data frame contents. There you go. 30, 35, 30, 34. That's exactly what we need. Okay. Now, allocation into Excel, which this is honestly the most easy part. Headers, we're gonna have data frame content. So using Pandas, the powerful package and library for tabulations in Python, we're gonna allocate this list into an Excel file. For step 4, we set the headers, which, as we indicated earlier, are gonna be this. Then we transform our data frame content list into a Pandas data frame. And if you see, we're gonna be printing the data frame. We're gonna have a very organized data frame. Company name, licenses. This data frame is 334 rows on length and 6 columns of width. It's very organized. It's 334 rows and by 6 columns, which is exactly what we intend for. Now we just convert this data frame into a usable, tangible PDF file. Not PDF, but CSV file or Excel file, up to you. I'm gonna use a CSV file. Let's call it PDF result. CSV, indexes false, we don't want any and headers. Yeah, let's just leave it like that. Now we're gonna run the program, and a file should be here. And just like that, ladies and gentlemen, we have allocated this into a usable, user-friendly data table. So as you can see, we have all of the names, we have all of the addresses, we have all of the persons, numbers, emails, and licenses. And just like that, we allocate data from a PDF into an Excel file. And we can distribute this file to our peers, or colleagues, or girlfriend. We can do anything that we want with Python. We can do anything that we want with programming. You only need three tools. Expertise, you need to know how to use the language. You need to know how to speak it, as I am speaking it right now. Even though this is not my first language, as you can tell, I learned how to do it. I learned how to speak this language efficiently, accurately, and most importantly, functional. It's all about the function. What are you doing that functions for something? So the 3 steps to be a great programmer, I believe, are expertise, knowing how to speak the languages; creativity, actually, let's do it in order. The top 3 things, or the top 3 attributes that makes a great programmer, or at least gives you the possibility to use the art of programming for your own benefit, for your own function, for something greater than you, is expertise, knowing how to speak the language, just as any other language: English, Mandarin, Spanish, Hungarian. You need how to speak the language, how to use it properly, proper grammar, proper semantics, etc. Creativity, you need how to apply certain rules of the language to certain things, to certain approaches, to certain automations, to certain optimizations. And then pattern recognition. You need a lot of pattern recognition, and this is, I know it sounds complex and perhaps boasting and self-absorbed, but actually pattern recognition is not only found in technical careers or in technical approaches. Pattern recognition is everywhere. You can look up, down, left, and right, and you will find patterns in what you're saying. Patterns are everywhere. But here, patterns, I think also mathematics and programming refine your pattern recognition ability, which is greatly used here, because creativity is like a symbiotic relationship. Creativity gives you the perspective to apply that pattern recognition, that expertise, to form something, to create something. Pattern recognition allows you to observe patterns that creativity and expertise can be applied to, and the expertise gives you the practical knowledge, the action to apply that creativity and pattern recognition into something tangible, to materialize something. So my recommendation here is to learn to code. I mean, you can do anything that you want. Honestly, I think code right now, it's magic. Code is an artistic form that combines functionality, creativity, pattern recognition, and design too. Because this is part of the design. I could have put this on a text format instead of an Excel file, but I decided not to, because I appreciate design. This design of this data is better than a text form or a dictionary, in my opinion. So those are the most crucial things about programming, and I hope this helped for you. And yeah, please expect more tutorials, more teachings. I'll try to do this more often. I'm currently working on a project, but I just wanted to do this. I just wanted to. Cheers.